go with question number 6. A man observes the angle of elevation of the top of a building to be 30 degrees. He walks towards it in a horizontal line through its base. On covering 60 meters, on covering 60 meter, the angle of elevation changes to 60 degrees. Find the height of the building correct to the nearest meter. So this is the question. A man observes the angle of elevation of the top of a building to be 30 degrees. He walks towards it in a horizontal line through its base. On covering 60 meter, the angle of elevation changes to 60 degrees. Find the height of the building correct to the nearest meter. First you note the question. I have to rub the board in order to, because you don't have much space on the board, so need to remove the question and then we'll start with. But before removing, let us draw the diagram. The diagram is like this. A man observes the angle of elevation of the top of the building. Suppose this is the building. So obviously the building lies on the ground. So our angle of elevation from here, if we look, this angle is 30 degrees. Right. Now he walks towards the building in the horizontal base on covering 60 meters, and suppose he has reached this point. So this distance is 60 meters. If we name it as A, B, C and D, then DC is 60 meters, and here again he looks at the point A, and this time the angle of elevation is 60 degrees. We have to find the height of the building. Let this height be H. So this is what is the diagram. This is the building. The person is at the point D. When he looks at the point A, the angle of elevation is 30 degrees. Then he moves 60 meters towards the building, and from there when he observes the point A, the angle of elevation is 60 degrees. We have to find the height of the building, that is H. Now we have two triangles ABC and ABD. So let us start with in triangle ABD. In triangle ABD we have, this is the perpendicular and this is the base. The proper ratio you have to take. So the perpendicular by base is tan. So tan of 30 degrees, we can write perpendicular H by this distance, and let this be x. If we take BC equals to x, so this is H by 60 plus x, or you can write H equals to 60 plus x by root 3, that is by tan 30, and tan 30 is 1 by root 3. So this is number 1. Again in triangle ABC, in triangle ABC, again we have the perpendicular and this is base. So we have tan of 60 degrees is equals to h by x. Tan 60 perpendicular by base h by x. So from here we can write h equals to x tan 60. So h is equals to root 3 into x. Tan 60 is root 3. Now from 1 and 2, h is 60 plus x by root 3, and here also h is root 3x. So from 1 and 2 we can write 60 plus x by root 3 is equal to root 3x. So that is from 1 and 2 we can write this. 60 plus x by root 3 is equals to root 3x. Now cross multiply, we have 60 plus x is equals to 3x. Root 3 into root 3 is x. So 60 is equals to 2x, or x equals to 30. So this part we have got 30. So we need to find the value of h. Now from equation 2, from 2 we have h equals to root 3 into x. So root 3 value is 1.732 and x is 30. So we have 17.32 into 3, we can write it as 6. 51.96 meters, and if you have to write to the nearest meter, that becomes 52 meters. So the height of this building is 52 meters. So hopefully you have understood. This is the triangle, the diagram. ABC, ABD is the triangle. So this is the building. The person is at the point D. When he looks at the point A, the angle of elevation is 30. Then he moves 60 meters towards the building, and from there when he looks at the point A, the angle of elevation is 60. We need to find the height of this building. So we have got two right angle triangles, ABC and ABD. So from in triangle ABD, tan of 30 degrees h by 60 plus x, and from this triangle tan of 60 is h by x. So we got two relations equating these two because both are h, and from there we get the value of x. Finally, when you got the value of x, putting the value of x in equation number 2, we have the value of h, which is coming to approximately 51.96, and to the nearest meter it is 52 meters. So this is question number 1. Now moving on to question number 2. Question number 2. From the top of a hill, the angles of depression, of two consecutive kilometer stones due east, means towards east, are found to be 30 degree and 45 degree respectively. Find the distance of the two stones from the foot of the hill. So this is the question. First you need to draw the diagram. Let us read the question once again. From the top of a hill, so the angles of depression of two consecutive kilometer stones due east are found to be 30 degrees and 45 degrees respectively. Find the distance of the two stones from the foot of the hill. So if this is the hill, see this is A, B, C and D. we are given the angles of depression, mind it. So angle of depression first you have to show on the diagram. So the angles of depression are 30 and 45. This is 45, this is 30. That means this angle is 30 and this angle is 45. Right? So this is the diagram. Now the kilometer stones are at C and D. So this is a very vital information here in the question. The distance between C and D we are given, that is 1 kilometer, because these are kilometer stones. So if you miss this out, then you won't be able to solve this problem. So the angles of depression of the 2 kilometer stones when are observed from the top of the hill are 30 degrees and 45 degrees. We need to find the distance of the 2 stones from the foot of the hill. That means you have to find BC and BD. So now here also you have got 2 right angle triangles, ABC and ABD. Let this be X and let us take this as H. So now starting with, let us first start with this triangle. In triangle ABC, perpendicular on base. So obviously the ratio tan will be applied. So tan of 45 degrees is equals to perpendicular by base, that is H by X, and the value of tan 45 is 1. So we have H is equals to X. So let us name it as A. Same in triangle ABD. Again, tan of 30 degrees is equals to H by X plus 1. H divided by X plus 1. This is X and this is 1. So X plus 1 is the total distance BD. So tan of 30 is perpendicular by the base BD, that is X plus 1. Now from here we can write H is equals to X plus 1 into tan of 30 degrees, and that is equals to X plus 1 by root 3. Tan 30 is 1 by root 3. So this we number it as 2. So from 1 and 2, here H equals to X and here H equals to X plus 1 by root 3, equating these two. So from 1 and 2 we have X is equals to X plus 1 by root 3, or you can write root 3x equals to X plus 1, or root 3 minus 1 into X equals to 1, or you can write X equals to 1 by root 3 minus 1. So H by X plus 1 tan 30, so H equals to X plus 1 into tan 30, X plus 1 by root 3. So X plus 1 by root 3 is equals to X from 1 and 2. Now you have to solve this. This X we have to rationalize, that becomes root 3 plus 1 by 3 minus 1. So that comes to 1.732 plus 1 by 2, that is 2.732 divided by 2, that is 1.366 kilometers. So the distance of the stone at C is 1.366 kilometers. Okay, so what is the distance of D? That is 1.366 plus 1. So we have distance of the stone at C is equals to X, and that is equals to 1.366 kilometer, and distance of the stone at D is equals to X plus 1, that is 1.366 plus 1 equals to 2.366 kilometers. So this is how we have to do this. So don't miss out this important information, the distance between the kilometer stones. It is given, so that that distance you have to take it as 1 kilometer. If you miss out that out, then it will be a problem in solving this particular question. So moving on to question number 3. The length of vertical straight tree 15 meter high, 15 meter high is broken by wind in such a way that its top reaches the ground and makes an angle of 60 degrees with the ground. At what height? At what height from the ground did the tree break? So now first let us draw the diagram for this. A vertical straight tree 15 meter high is broken by wind in such a way that its top reaches the ground and makes an angle of 60 degrees with the ground. At what height from the ground did the tree break? So let us take this as the tree. This is the ground, and let this tree be broken from this point. So this part of the tree is broken, so it will fall on the ground. This one. If it is A, this is B, this is C, and this is D. That means AB, the part AB and BD are equal. This is the part I am marking it to dotted line, which is broken, and it reaches the ground, touches the ground at the point D. And this makes an angle of 60 degrees. This total height is 15 meters. So let us take this part as x, then this is 15 minus x, and if this is 15 minus x, then this is 15 minus x. But this part is the one which is broken, and this is the BD is the part AB. So AB and BD. AB is same as the part BD, which is the broken part. We need to find the value of x, that means the height from the ground where the tree has broken. So we need to find x. So this triangle, we can apply the ratio. This is perpendicular and this is hypotenuse. So sine ratio is applicable. Let us start with this. Sine of 60 degrees equals to perpendicular by hypotenuse, that is x by 15 minus x. So x is equals to 15 minus x, and sine 60 is root 3 by 2. So we have 2x equals to 15 root 3 minus root 3x. So we have 2 plus root 3 into x is equals to 15 root 3. So can write x is equals to 15 root 3 by 2 plus root 3. We rationalize it. 2 minus root 3 divided by 2 minus root 3. So it is 15 root 3 into 2 minus root 3 divided by, this is 4 minus 3. So this will become 30 root 3 minus 45. So this is 30 into 1.732 minus 45. So 3 into 17.32 minus 45, this is 6, 9, 51.96 minus 45. So this will be the required height from where the tree has broken. So let us calculate this. This is coming to this 6 point, almost approximately 6.9 meters it is coming. Just check it. Approximately it is 6.9 meters. So it is 6.9 meters above the ground from where the part of the tree is broken and has reached the ground. So this is question number 3. Now moving on, next question is 8. I think this will be question number 9. I marked it wrong. Now question number 9. A vertical tower stands on a horizontal plane. Stands on a horizontal plane and is surmounted by a vertical flagstaff of height h. At a point on the plane. At a point on the plane, the angle of elevation of the bottom of the flagstaff is alpha and that of the top of the flagstaff is beta. Prove that the height of the tower is h tan alpha divided by tan beta minus tan alpha. So this is the question. Let us read it out once again. A vertical tower stands on a horizontal plane and is surmounted by a vertical flagstaff. Now first of all, a vertical tower. This is the vertical tower. This is the ground. Right. Now if this is the tower, at the top of the tower a flagstaff is here. The height of this flagstaff is h. This part is h. Now at a point on the plane, this is the plane, from this point, supposing the angle of elevation of the bottom of the flagstaff, that means if you look at this point, this angle is alpha and that of the top of the flagstaff, if you look at this point, so this angle is beta. We need to prove that the height of the tower is h tan alpha. That means if this is x, let this height of the tower, let it be x, and this is h. So we have to find the value of x, the height of the tower. So again, let us take this as y. Supposing we have two right angle triangles, A, B, C, and D. Triangle ACD and triangle BCD. So start with the first one. In triangle BCD, this is perpendicular, this is base. So tan of alpha equals to x by y. So let's make y the subject, so y equals to x by tan alpha. Let us name it as 1. Secondly, in triangle ACD, again we can apply the ratio tan, because tan of beta is h plus x by y. This is h plus x by y. From here we have y equals to h plus x by tan beta. Let us name it as 2. So from 1 we have y equals to x by tan alpha, and from 2 y equals to h plus x by tan beta. So equating these two from 1 and 2, we have to get this. So from 1 and 2 we have x by tan alpha is equals to h plus x by tan beta. We have to find x. So let us eliminate x from these two. So we have x into tan of beta equals to h tan alpha plus x tan alpha. So let us write it x into tan beta minus tan alpha is equals to h tan alpha. So we have x equals to h tan alpha divided by tan beta minus tan alpha, and which is the required output. Hopefully you have understood this. Questions are simple, but then you have to see to the ratios, the values of the standard angles, all these things you need to remember. So moving on to the next question, question number 10. So the question number 10 goes like this. The angles of elevation of the top of a tower from 2 points P and Q at a distance A and B, distance of A and B respectively from the base and in the same straight line, and in the same straight line with it are complementary. Prove that the height of the towers is root over A into B. So The question is like this: the angles of elevation of the top of a tower from 2 points P and Q at a distance of A and B respectively from the base and in the same straight line with each are complementary. So let us have the diagram. The angle of elevation on top of a tower. So this is the tower. This, let us take this point as P and this point as Q. This distance from this is A, and this distance, let us take this as B. The angle of elevation you have to do this one, and this is another one. This is alpha. We have been given that the two angles are complementary. Complementary angles, you know, the sum of the two angles is 90 degrees. So if you take this angle as theta, then this angle will be 90 minus theta. So we need to find the height of the tower. Let this be A, B, Q and P. So P and Q are, P is at a distance of A units from B and Q is at a distance of P units from B. We need to find the height of the tower. So again, let us take this as h. So in triangle, if you take this as h, we have the ratios perpendicular and base, so this will be tan. So in triangle ABQ, tan of 90 minus theta is h by b. Tan 90 minus theta is cot theta, that is h by b, or you can write h equals to b cot theta. So again, in triangle ABP, we have tan of theta is equals to h by a. So you can write h equals to a tan theta. So this is number 1 and this is number 2. We have only taken the ratios in terms of tan. So tan of 90 is perpendicular by base, that is h by a, and tan 90 minus theta is h by b. And tan of 90 minus theta is cot theta, so cot theta is h by b. So from here h is b cot theta, from here h is a tan theta. Now we need to find the value of the height of the tower, that is h. So what you do, we will multiply the two results that you obtain in 1 and 2. So multiply 1 and 2. So we have h into h, that is h square is equals to b cot theta multiplied by a tan theta. So it is a into b, and cot theta is 1 by tan theta, that they are reciprocal ratios. These two are reciprocal ratios. So we have h square equals to ab, or h equals to root over ab, and thereby the height of the tower is obtained as root over ab units. So go through this. Moving on to the next question, that is question number 11. If you have finished writing, then I will just remove it now. So let us take question number 11. Two pillars of equal height. Two pillars of equal height are on the either side of a road. Either side of a road, which is 100 meter wide. Which is 100 meter wide. The angle of elevation. The angle of elevation of the top of the two pillars, of the top of the two pillars are 60 degree and 30 degree. At a point on the road, between the pillars, find the position of the point. Find the position of the point between the pillars and also find the height of the pillars. Also find the height of the pillars. And according to the question, the height of the pillars are the same. So the two pillars of equal height are on the either side of the road. So let this be one pillar. This is the road and this is the other pillar. Both are of equal height. And the width is 100 meters. So this width is 100 meters. The angle of elevation of the top of the two pillars are 60 and 30 at a point on the road between the pillars. So at a point, suppose you take this point, if you look at this pillar, the angle of elevation is 60 degrees, and if you look at this pillar, the angle of elevation is 30 degrees. A, B, C, D, E. The pillars are AB and DE. The width of the road is 100 meters, that is BD, and the position of the point between the two pillars on the road is at C. From here, if you look at the top of this, that is E, angle of elevation 60, looking at the point A, angle of elevation 30. Find the position of the point between the pillars. So you need to find the position of the point C, that means at what distance it is from the from point B, or at what distance it is from the point D, and also the height AB and DA. So let this be H, because both are same. So again we can have, if this be X, then this is 100 minus X. Total distance 100. This part CD you have taken it as X. Then BC is 100 minus X. This is H, this is H. So applying the trigonometrical ratio, perpendicular by base. So we start with, in triangle ABC, we can write tan of 30 degree is equals to H by 100 minus X. So we have H equals to 100 minus X into tan 30, and tan 30 is 1 by root 3, so write it directly like this. 100 minus X by root 3 from equation, it forms the equation 1. Now moving on to the second triangle, that is in triangle CDE. All are right angle triangles. So in triangle CDE, we have tan 60 is equals to H by X. So what is H? X into tan 60, and tan 60 is root 3, so this is root 3x. This is number 2. Now from 1 and 2, from 1 and 2, we have root 3x is equals to 100 minus x by root 3. So root 3x, so it becomes 3x equals to 100 minus x. So 4x equals to 100, or x equals to 25 meter. That means the point C, which is in between B and D, is at a distance of 25 meters from the end D, that is from D, and it will be at a distance of 75 meters from the point B. So the position C, so C is at a distance of 25 meters from D, and C is at a distance of 100 minus 25, and that is equals to 75 meters from the point B, from B. Now also, since you have found the first part of the question, the second part of the question asks for the height of the pillars which are the same. So we can put the value in any one of the equations, 1 or 2, so putting it in 2, so we have h equals to root 3 into x. So it is root 3 into x, the value of x is 25. So this is 1.732 into 25. So you have to multiply this. Let me calculate it. This is coming to 1.732 into 25. So it is coming to 43.25. 43.25 meters. So this is the first part of the question, that is the position of the point C in between the two pillars on the road, and this is the height of the two pillars which are already the same according to the question.